All right, this video will cover a challenge and a real-world connection in our work with multiplying special cases, basically multiplying binomials and looking at some special cases there. So I encourage you to pause this video, try these on your own, see how you did, and then follow along and check back in. So first we're going to multiply. On the left side here we have something to the fourth, so that's a bigger power than what we've been working with before. But what I'm going to do first, well, I guess let me write it out. So whenever we raise something, we're raising something to the fourth. Whenever we raise something to a power, that's just telling us how many times we multiply. So that's a sort of longhand version of the same problem. And look what we have. We have 2x plus 3 quantity squared, and then another 2x plus 3 quantity squared. Okay? So we can think of this like so. We're going to square something, and then we're going to square it again. So let's do just the squaring first, the initial squaring, and we can follow our shortcut with perfect squares, but I'm actually going to write it out just to make sure we do it correctly. So we do a 2x plus 3, 2x plus 3. So first are 4x squareds. Outers and inners combined together to be twice any individual one of them. So outers and inners are the same, so we can do it more quickly by just doubling one of them. So the outers is 6x, so we'll have a 12x, and then the lasts are 9. Okay, so now we need to square that. Okay, so let's make sure we're being careful with our notation here to represent what we're working on. So to square this problem, we again need to multiply it by itself. We can't just distribute the exponent through. Okay, so I'm going to turn this into a 4x squared plus 12x plus 9 times another 4x squared plus 12x plus 9. Okay, and the challenge here is to just make sure each term in the first set of parentheses gets multiplied by each term in the second set of parentheses. So I'm going to take this 4x squared and multiply it through. I'm going to take the 12x and multiply it through, and I'm going to take the 9 and multiply it through. So we have a lot of combinations to work with. Okay, so a big challenge here is just staying organized and making sure we're doing everything carefully. So I'm going to multiply this guy through first. So 4x squared times 4x squared is 16x to the fourth. And then times the 12x is 48x cubed. And then times the 9 is 36x squared. Okay, so that was the result of multiplying that first 4x squared term through. Now I'm going to multiply this guy through, plus 12x. I'm just going to do it on a different line so I save some space. 12x times 4x squared is 48x cubed plus 144x squared plus 9 times 12, I think is, what is it? 108 plus 108x. Okay, so that's the result of multiplying that orange one all the way through. Now I'm going to multiply the 9 all the way through. So then we have a plus 9, well 9 times 4 is 36. 36x squared, 9 times 12 is still 108x plus 81. Okay, so that's the result of multiplying the 9 all the way through. So we have some simplifying to do, but we did the bulk of the challenging stuff. When you simplify, we're going to be adding all these together. I think it's easiest just to go term by term, so power by power. So let's look at the fourth powers first, and then we can cross off as we go. So we have 1/4 power, 16x to the fourth. Let me just cross that off. What are our cubes? We have 2 cubed powers, a 48 and a 48x cubed, so that's 96x cubed. Let's look at our squareds. We have a 36, a 36, and a 144. So let's add all those two together, or all those three together. So that's 216x squared. Look at our x terms. We have two 108s, so that's 216x, and then we just have an 81 right there. So that is our final answer right there, and that's a long and complicated problem. All right, let's go to the real world connection problem, another patio problem. I love these guys. You have a square patio in your backyard. Let's draw a picture here. Oops, here, let me get that a little bit better. And let's not think of this as being perfectly to scale. Is that even a square? It's pretty close to a square, okay? So each grid square on my graph paper doesn't represent 1 foot or anything. So anyway, we have a square patio in our backyard. We want to change the shape of it by pushing one edge out by 5 feet and the other edge in by 5 feet. Okay, so let's see. So we want this to be bigger. So we're pushing it out by 5 feet. But then we're bringing this edge in by 5 feet. Okay, so we're bringing it in by 5 feet. So this, I think you can see that this piece is going to go away, right? So our final outcome, our final patio is going to look like this. It's going to be a little bit of a longer and skinnier rectangle than we had before. Okay, so that's going to be our brick patio right there, okay? And then the question is, it won't change the overall area, right? I guess we have to figure that out. Or maybe not. Let's check it out. Does it depend on the original dimensions of the patio? So I'm not giving you the original dimensions of the patio. Presumably the patio is larger than 5 feet by 5 feet, because if we reduced one edge in by 5 feet, that would bring it down to 0. So we have to assume the patio is at least 5 by 5 to begin with. But let's get some numbers written in, or not some numbers, but some variables. So this is x, and this is 5, and this is x, and this is 5. Okay, so our original patio was x squared, right? And our new patio is x plus 5 times x minus 5. Okay, I hope you can see that this new dimension here is going to be an x minus 5. All right, let's FOIL that out. Let's multiply it out. That's a special case. It's going to result in a difference of 2 squareds, and we have an x squared minus 25. So let's think about what that means. Our new patio was x by x, or excuse me, our original patio was x by x, and our new one is that same x by x minus 25. So the new patio must be smaller. It doesn't matter what x is. It must be a smaller area overall. It'll be 25 square feet less. That's pretty cool. It doesn't matter what x was. It could have been a 1,000 by 1,000 foot patio, and if we increase one side by 5 and the other side we bring in by 5, the new patio will be 25 square feet less. All right, that's a good place to stop.